Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You have an application where the frontend is deployed on a managed instance group in Subnet A and the data layer is stored on a MySQL Compute Engine virtual machine, VM, in Subnet B on the same VPC. Subnet A and Subnet B hold several other Compute Engine VMs. You only want to allow the application frontend to access the data in the application's MySQL instance on port 3306. What should you do? The options are: Option A, configure an ingress firewall rule that allows communication from the src IP range of Subnet A to the tag data tag that is applied to the MySQL Compute Engine VM on port 3306. Option B, configure an ingress firewall rule that allows communication from the frontend's unique service account to the unique service account of the MySQL Compute Engine VM on port 3306. Option C, configure a network tag FATAG to be applied to all instances in Subnet A and a network tag data tag to be applied to all instances in Subnet B. Then configure an egress firewall rule that allows communication from Compute Engine VMs tagged with data tag to destination Compute Engine VMs tagged FATAG. Option D, configure a network tag FATAG to be applied to all instances in Subnet A and a network tag data tag to be applied to all instances in Subnet B. Then configure an ingress firewall rule that allows communication from Compute Engine VMs tagged with FATAG to destination Compute Engine VMs tagged with data tag.
To arrive at the correct answer, we focus on the keywords. Frontend is deployed on a managed instance group in Subnet A, MySQL Compute Engine Virtual Machine, VM, in Subnet B. Subnet A and Subnet B hold several other Compute Engine VMs. Only want to allow the application frontend to access the data in the application's MySQL instance on port 3306.
The correct answer is option B, configure an ingress firewall rule that allows communication from the frontend's unique service account to the unique service account of the MySQL Compute Engine VM on port 3306.
Why is this correct? B. Using unique service accounts for firewall rules provides the most granular access control. This guarantees that only the specific frontend VMs can access the MySQL instance, correctly excluding other VMs in the subnets. Why are the others incorrect? A. Allowing access from the entire source IP range of Subnet A is too broad. Since Subnet A contains other VMs, this would allow unintended instances to access the database. C. Tagging all instances in both subnets provides excessively broad access. Additionally, this configures an egress rule instead of an ingress rule on the database, which isn't the most effective control. D. Applying a network tag to all instances in Subnet A grants access to every VM in that subnet. This violates the requirement to only allow the application frontend.
An administrative application is running on a virtual machine, VM, in a managed group at port 5601 inside a virtual private cloud, VPC, instance without access to the internet currently. You want to expose the web interface at port 5601 to users and enforce authentication and authorization Google credentials. What should you do? The options are: Option A, configure the Bastion host with OS login enabled and allow connection to port 5601 at VPC Firewall. Log in to the Bastion host from the Google Cloud Console by using SSH in browser and then to the web application. Option B, modify the VPC routing with the default route point to the default Internet gateway. Modify the VPC firewall rule to allow access from the Internet 0.0.0.0/0 to port 5601 on the application instance. Option C, configure Secure Shell Access, SSH, Bastion host in a public network, and allow only the Bastion host to connect to the application on port 5601. Use a Bastion host as a jump host to connect to the application. Option D, configure an HTTP load balancing instance that points to the managed group with Identity-Aware Proxy (IAP) protection with Google credentials. Modify the VPC firewall to allow access from IAP network range.
To arrive at the correct answer, we focus on the keywords: expose the web interface at port 5601, enforce authentication and authorization Google credentials.
The correct answer is option D. Configure an HTTP load balancing instance that points to the managed group with Identity-Aware Proxy (IAP) protection with Google credentials. Modify the VPC firewall to allow access from IAP network range.
Why is this correct? D. IAP securely authenticates users via Google credentials before granting access. Using an HTTP load balancer with IAP is the Google recommended method to securely expose a web interface without making the VMs directly accessible to the Internet. Why are the others incorrect? A. A Bastion host and SSH browser are designed for remote terminal access to VMs, not for seamlessly exposing a web interface to users or managing web-based application authentication. B. Opening port 5601 directly to the entire Internet, 0.0.0.0/0, exposes the application without enforcing Google credential-based authentication, which is highly insecure and violates the requirements. C. Using an SSH Bastion jump host provides terminal access rather than securely exposing a web interface, and it fails to leverage native Google credential authorization for web applications.
Your organization wants to be continuously evaluated against CIS Google Cloud Computing Foundation's benchmark version 1.3.0, CIS Google Cloud Foundation 1.3. Some of the controls are irrelevant to your organization and must be disregarded in evaluation. You need to create an automated system or process to ensure that only the relevant controls are evaluated. What should you do? The options are: Option A, mark all security findings that are irrelevant with a tag and a value that indicates a security exception. Select all marked findings, and mute them on the console every time they appear. Activate Security Command Center, SCC, Premium. Option B, activate Security Command Center, SCC, Premium. Create a rule to mute the security findings in SCC so they are not evaluated. Option C, download all findings from Security Command Center, SCC, to a CSV file. Mark the findings that are part of CIS Google Cloud Foundation 1.3 in the file. Ignore the entries that are irrelevant and out of scope for the company. Option D, ask an external audit company to provide independent reports including needed CIS benchmarks. In the scope of the audit, clarify that some of the controls are not needed and must be disregarded.
To arrive at the correct answer, we focus on the keywords: continuously evaluated, controls are irrelevant, disregarded in evaluation, automated system or process, only the relevant controls are evaluated.
The correct answer is option B, activate Security Command Center, SCC, Premium. Create a rule to mute the security findings in SCC so they are not evaluated.
Why is this correct? B. SCC Premium provides built-in compliance monitoring against CIS benchmarks. Mute rules automatically hide findings based on specified criteria, fulfilling the requirement for an automated process to disregard irrelevant controls continuously. Why are the others incorrect? A. Muting findings manually on the console every time they appear is a manual action, not an automated system or process, adding unnecessary operational overhead. C. Downloading findings to a CSV file and manually ignoring entries is not an automated system or process and does not provide continuous evaluation. D. Relying on an external audit company provides point-in-time reports rather than a continuous, automated system or process for evaluation.
In a shared security responsibility model for IaaS, which two layers of the stack does the customer share responsibility for? Choose two. The options are: Option A, hardware. Option B, network security. Option C, storage encryption. Option D, access policies. Option E, boot.
To arrive at the correct answer, we focus on the keywords, Shared Security Responsibility Model, IaaS, Customer Share Responsibility.
The correct answers are option B, network security, and option D, access policies.
Why is this correct? B. Network security is a shared responsibility in IaaS. The provider secures the physical network infrastructure, while the customer configures virtual firewalls, routing, and workload-level network access. D. Access policies are a shared responsibility in IaaS. The provider secures the underlying identity system, while the customer defines and manages user access, roles, and permissions. Why are the others incorrect? A. In IaaS, the cloud provider is entirely responsible for the physical hardware, including servers and facilities. The customer has no responsibility for this layer. C. While the customer is responsible for their data, the underlying storage infrastructure and default storage encryption mechanisms are managed by the cloud provider. E. The boot process of the underlying physical infrastructure and hypervisors is solely managed and secured by the cloud provider in an IaaS environment.
Your organization recently activated the Security Command Center, SCC, standard tier. There are a few cloud storage buckets that were accidentally made accessible to the public. You need to investigate the impact of the incident and remediate it. What should you do? The options are option A, 1. Remove the Identity and Access Management, IAM, granting access to all users from the buckets. Point 2. Apply the organization policy storage. Uniform bucket level access to prevent regressions. Point 3. Query the data access logs to report on unauthorized access. Option B, 1. Change permissions to limit access for authorized users. Point 2. Enforce a VPC Service Controls perimeter around all the production projects to immediately stop any unauthorized access. Point 3. Review the administrator activity audit logs to report on any unauthorized access. Option C, 1. Change the bucket permissions to limit access. Point 2. Query the bucket's usage logs to report on unauthorized access to the data. Point 3. Enforce the organization policy storage. Public access prevention to avoid regressions. Option D, 1. Change bucket permissions to limit access. Point 2. Query the data access audit logs for any unauthorized access to the buckets. Point 3. After the misconfiguration is corrected, mute the finding in the Security Command Center.
To arrive at the correct answer, we focus on the keywords, cloud storage buckets, accidentally made accessible to the public, investigate the impact, remediate it.
The correct answer is option C, 1. Change the bucket permissions to limit access. Point 2. Query the bucket's usage logs to report on unauthorized access to the data. Point 3. Enforce the organization policy storage. Public access prevention to avoid regressions.
Why is this correct? C. Modifying bucket permissions immediately halts unauthorized access. Usage logs reveal who accessed the data to assess impact. The storage. Public access prevention policy specifically ensures buckets cannot be made public, preventing regressions. Why are the others incorrect? A. The storage. Uniform bucket level access policy only unifies access control and does not prevent public access. Furthermore, data access audit logs are disabled by default and may not be available for investigation. B. Administrator activity audit logs record administrative actions, not object-level data access. Immediately enforcing VPC service controls without planning could also break existing authorized workflows. D. Muting the SCC finding merely hides the alert. It does not implement a policy guardrail to prevent the misconfiguration from happening again.
Your application is deployed as a highly available, cross-region solution behind a global external HTTP/S load balancer. You notice significant spikes in traffic from multiple IP addresses, but it is unknown whether the IPs are malicious. You are concerned about your application's availability. You want to limit traffic from these clients over a specified time interval. What should you do? The options are Option A. Configure a throttle action by using Google Cloud Armor to limit the number of requests per client over a specified time interval. Option B. Configure a rate_based_ban action by using Google Cloud Armor and set the ban_duration_ACC parameter to the specified time interval. Option C. Configure a firewall rule in your VPC to throttle traffic from the identified IP addresses. Option D. Configure a deny action by using Google Cloud Armor to deny the clients that issued too many requests over the specified time interval.
To arrive at the correct answer, we focus on the keywords: global external HTTP/S, load balancer, significant spikes in traffic, unknown whether the IPs are malicious, limit traffic, specified time interval.
The correct answer is option A. Configure a throttle action by using Google Cloud Armor to limit the number of requests per client over a specified time interval.
Why is this correct? A. The throttle action in Google Cloud Armor limits requests to a configured threshold over a specified time interval, mitigating spikes without completely blocking IPs when it is unknown if they are malicious. Why are the others incorrect? B. A rate_based_ban completely blocks traffic from the IP for a set duration once the threshold is met, which is overly aggressive since it is unknown whether the IPs are actually malicious. C. VPC firewall rules allow or deny traffic but cannot throttle traffic or enforce rate limits. Furthermore, Cloud Armor is the appropriate tool for protecting global external HTTP/S load balancers. D. A deny action blocks traffic from the IPs, which is inappropriate because the IPs are not confirmed to be malicious and the requirement is only to limit traffic, not block it.
You are a consultant for an organization that is considering migrating their data from its private cloud to Google Cloud. The organization's compliance team is not familiar with Google Cloud and needs guidance on how compliance requirements will be met on Google Cloud. One specific compliance requirement is for customer data at rest to reside within specific geographic boundaries. Which option should you recommend for the organization to meet their data residency requirements on Google Cloud? The options are Option A. Organization Policy Service Constraints. Option B. Shielded VM instances. Option C. Access Control Lists. Option D. Geolocation Access Controls. Option E. Google Cloud Armor.
To arrive at the correct answer, we focus on the keywords: customer data at rest to reside within specific geographic boundaries, data residency requirements.
The correct answer is option A. Organization Policy Service Constraints.
Why is this correct? A. Organization Policy Service allows administrators to configure a resource location restriction constraint. This constraint enforces that Google Cloud resources can only be created within designated geographic regions, effectively meeting data residency and location requirements. Why are the others incorrect? B. Shielded VM instances offer verifiable integrity to protect against rootkits and boot-level malware. They do not enforce geographic restrictions on where data is stored. C. Access control lists manage user or service account permissions for accessing resources. They cannot restrict the physical geographic location where data resides at rest. D. Geolocation access controls restrict incoming user requests based on their origin location, but they do not dictate the physical location where the organization's data is stored. Why are the others incorrect? E. Google Cloud Armor provides DDoS protection and web application firewall capabilities. While it can filter traffic by geography, it cannot enforce data residency policies for stored data.
Users are reporting an outage on your public-facing application that is hosted on Compute Engine. You suspect that a recent change to your firewall rules is responsible. You need to test whether your firewall rules are working properly. What should you do? The options are Option A. Enable firewall rules logging on the latest rules that were changed. Use Logs Explorer to analyze whether the rules are working correctly. Option B. Connect to a Bastion host in your VPC. Use a network traffic analyzer to determine at which point your requests are being blocked. Option C. In a pre-production environment, disable all firewall rules individually to determine which one is blocking user traffic. Option D. Enable VPC flow logs in your VPC. Use Logs Explorer to analyze whether the rules are working correctly.
To arrive at the correct answer, we focus on the keywords: outage on your public-facing application, recent change to your firewall rules, test whether your firewall rules are working properly.
The correct answer is option A. Enable firewall rules logging on the latest rules that were changed. Use Logs Explorer to analyze whether the rules are working correctly.
Why is this correct? A. Firewall rules logging allows you to view which specific firewall rules are allowing or denying traffic to your instances, directly revealing if the recent changes caused the outage. Why are the others incorrect? B. Connecting to a bastion host and using a third-party network analyzer is overly complex and less effective than using GCP's native, purpose-built firewall rules logging. C. Disabling rules individually in a pre-production environment is a manual, inefficient trial-and-error approach that doesn't provide direct visibility into which rule is actually blocking traffic in production. D. VPC flow logs record network connection data like IPs and ports but do not log which specific firewall rule allowed or denied a packet, making it insufficient for this task.
You want to prevent users from accidentally deleting a shared VPC host project. Which organization-level policy constraint should you enable? The options are: Option A. Compute.restrict shared VPC host projects. Option B. Compute.restrict XPN project lien removal. Option C. Compute.restrict shared VPC subnetworks. Option D. Compute.shared reservations owner projects.
To arrive at the correct answer, we focus on the keywords: prevent users from accidentally deleting, shared VPC host project, organization-level policy constraint.
The correct answer is option B. Compute.restrict XPN project lien removal.
Why is this correct? B. This constraint restricts the removal of project liens on shared VPC host projects. Because a project cannot be deleted while a lien is present, enforcing this policy prevents accidental deletion. Why are the others incorrect? A. This constraint is used to restrict which projects can be configured as shared VPC host projects within the organization, not to prevent their deletion. C. This constraint restricts which subnetworks can be shared in a shared VPC, unrelated to preventing the deletion of the host project. D. This constraint restricts which projects can own shared compute reservations, which is entirely unrelated to shared VPC host project deletion.
You need to enable VPC service controls and allow changes to perimeters in existing environments without preventing access to resources. Which VPC service controls mode should you use? The options are: Option A. Cloud Run. Option B. Native. Option C. Enforced. Option D. Dry Run.
To arrive at the correct answer, we focus on the keywords: enable VPC service controls, allow changes to perimeters, without preventing access to resources.
The correct answer is option D. Dry Run.
Why is this correct? D. Dry Run mode allows you to test perimeter changes and monitor violations without blocking any access to resources, making it ideal for existing environments. Why are the others incorrect? A. Cloud Run is a managed compute platform for deploying containerized applications, not a VPC service controls mode. B. There is no native mode in VPC service controls. The two primary modes are enforced and dry run. C. Enforced mode actively blocks requests that violate the perimeter configuration, which would prevent access to resources contrary to the requirements.
You are a member of your company's security team. You have been asked to reduce your Linux Bastion host external attack surface by removing all public IP addresses. Site reliability engineers, SREs, require access to the Bastion host from public locations so they can access the internal VPC while off-site. How should you enable this access? The options are Option A, implement Cloud VPN for the region where the Bastion host lives. Option B, implement OS login with two-step verification for the Bastion host. Option C, implement identity-aware proxy TCP forwarding for the Bastion host. Option D, implement Google Cloud Armor in front of the Bastion host.
To arrive at the correct answer, we focus on the keywords, removing all public IP addresses, access to the Bastion host from public locations.
The correct answer is option C, implement identity-aware proxy TCP forwarding for the Bastion host.
Why is this correct? C. IAP TCP forwarding enables you to establish secure SSH connections to VM instances lacking external IP addresses. It securely tunnels traffic from public locations to your internal VPC without requiring a public IP on the Bastion host. Why are the others incorrect? A. Cloud VPN is designed to connect on-premises networks to Google Cloud via site-to-site IPsec, not for individual users connecting from various public locations. It would require additional client-to-site infrastructure. B. OS login securely manages SSH access and adds two-step verification, but it does not route traffic or provide network connectivity to instances lacking public IP addresses. D. Google Cloud Armor provides DDoS protection and WAF capabilities for HTTP/HTTPS load balancers. It is not designed to broker or secure SSH access to VM instances.
You recently joined the networking team supporting your company's Google Cloud implementation. You are tasked with familiarizing yourself with the firewall rules configuration and providing recommendations based on your networking and Google Cloud experience. What product should you recommend to detect firewall rules that are overlapped by attributes from other firewall rules with higher or equal priority? The options are Option A, Security Command Center. Option B, Firewall Rules Logging. Option C, VPC Flow Logs. Option D, Firewall Insights.
To arrive at the correct answer, we focus on the keywords, detect firewall rules that are overlapped by attributes from other firewall rules with higher or equal priority.
The correct answer is option D, Firewall Insights.
Why is this correct? D. Firewall Insights is specifically designed to optimize firewall configurations. It automatically analyzes rules and provides insights to detect shadowed or overlapping firewall rules that are superseded by other rules with higher or equal priority. Why are the others incorrect? A. Security Command Center is a centralized risk management platform for detecting vulnerabilities and threats, but it does not analyze or detect overlapping firewall rules. B. Firewall Rules Logging records connections allowed or denied by rules for traffic analysis, but it does not proactively identify overlapping or shadowed rule configurations. C. VPC Flow Logs record network traffic flows sent and received by VM instances for network monitoring and forensics, not for detecting overlapping firewall rule definitions.
Your organization has had a few recent DDoS attacks. You need to authenticate responses to domain name lookups. Which Google Cloud service should you use? The options are Option A, Cloud DNS with DenSec. Option B, Cloud NAT. Option C, HTTPS load balancing. Option D, Google Cloud Armor.
To arrive at the correct answer, we focus on the keywords, authenticate responses, domain name lookups.
The correct answer is option A, Cloud DNS with DenSec.
Why is this correct? A. Cloud DNS with DenSec adds cryptographic signatures to DNS records. This allows resolvers to authenticate responses to domain name lookups, ensuring data integrity and protecting against DNS spoofing and cache poisoning. Why are the others incorrect? B. Cloud NAT provides outbound internet access for private instances. It does not handle DNS resolution or provide any mechanisms to authenticate domain name lookups. C. HTTPS load balancing distributes web traffic across backend instances. While it helps absorb DDoS attacks, it operates at the application layer and does not authenticate DNS responses. D. Google Cloud Armor provides WAF and DDoS protection for applications. It does not provide domain name resolution services or DNSSEC capabilities to authenticate DNS lookups.
You are a security engineer at a finance company. Your organization plans to store data on Google Cloud, but your leadership team is worried about the security of their highly sensitive data. Specifically, your company is concerned about internal Google employees' ability to access your company's data on Google Cloud. What solution should you propose? The options are: Option A, use customer-managed encryption keys. Option B, use Google's Identity and Access Management (IAM) service to manage access controls on Google Cloud. Option C, enable admin activity logs to monitor access to resources. Option D, enable access transparency logs with access approval requests for Google employees.
To arrive at the correct answer, we focus on the keywords: internal Google employees' ability to access your company's data on Google Cloud.
The correct answer is option D, enable access transparency logs with access approval requests for Google employees.
Why is this correct? D. Access transparency logs provide visibility into Google staff actions. Access approval allows you to explicitly approve or deny Google administrators' requests to access your data. Why are the others incorrect? A. Customer-managed encryption keys give you control over encryption keys, but do not provide logging or approval mechanisms for internal Google personnel access. B. Google Cloud IAM is used to manage access for your organization's users and service accounts, not for internal Google employees. C. Admin activity audit logs record actions taken by your organization's identities, not administrative actions performed by internal Google personnel.
As adoption of the Cloud Data Loss Prevention (Cloud DLP) API grows within your company, you need to optimize usage to reduce cost. Cloud DLP target data is stored in cloud storage and BigQuery. The location and region are identified as a suffix in the resource name. Which cost reduction options should you recommend? The options are: Option A, set appropriate rows limit value on BigQuery data hosted outside the US and set appropriate bytes limit per file value on multi-regional cloud storage buckets. Option B, set appropriate rows limit value on BigQuery data hosted outside the US and minimize transformation units on multi-regional cloud storage buckets. Option C, use rows limit and bytes limit per file to sample data and use cloud storage regex file set to limit scans. Option D, use finding limits and time span config to sample data and minimize transformation units.
To arrive at the correct answer, we focus on the keywords: optimize usage to reduce cost, stored in cloud storage and BigQuery, location and region are identified as a suffix in the resource name.
The correct answer is option C, use rows limit and bytes limit per file to sample data and use cloud storage regex file set to limit scans.
Why is this correct? C. Rows limit and bytes limit per file sample BigQuery and cloud storage data to reduce processing volumes. Cloud storage regex file set uses the resource name suffix to precisely target specific locations, drastically minimizing the amount of data scanned and reducing costs. Why are the others incorrect? A. While rows limit and bytes limit per file are valid sampling methods, restricting this recommendation only to data outside the US or multi-regional buckets ignores the regex filtering potential of the resource name suffix. B. Minimizing transformation units does not effectively reduce initial data scanning costs. Additionally, arbitrarily limiting cost optimization to non-US or multi-regional data misses the opportunity to optimize globally using regex filtering. Why are the others incorrect? D. Finding limits limits the number of findings returned, not the data scanned, failing to reduce scanning costs. Timespan config applies to time-partitioned BigQuery or data store data, not cloud storage regex filtering.